In this video, I'm going to cover some of the problems from our final exam review. Okay, so for instance, we want to answer this question: for which of the following numbers is not in this domain? For this function, we know with square roots we can't take the square root of a negative number, so we need whatever inside to be not negative, which means that's got to be greater than or equal to 0. If we solve this inequality, subtract 1, divide by 2, you get that x is got to be greater than or equal to negative 1/2. So which of the numbers listed is not bigger than or equal to negative 1/2? That's negative 1. That's to the left. That's less than negative 1/2. For the second one, you want to know what is the domain of this function. Here you're dividing by different numbers. When you plug different numbers in for x, you're going to get different denominators. If you factor the denominator as x plus 4 times x minus 1, you see that that will be 0, which is bad if x is negative 4 or 1. So we got to exclude those two numbers. We do not want x to be negative 1 or positive 1 or negative 4. Whenever we graph a function, for the third one, it's always y equals j of x. So if we're given y equals 14, we want to know, is there an x that satisfies the value of the function is 14? Well, we set up that equation, we solve it, we actually get two solutions, plus or minus the square root of 13. So yes, that is in the range of that function. For the next one, we're given a function, we're supposed to plug in a number in a variable expression. Let's just clean it off and then plug it in. So we want to plug in 3 for x. We do 2 times, negative 3. Plug in negative 3 wherever we see an x. Follow the order of operations after that to simplify and evaluate the expression. So evaluate the function at negative 3. So in this case, we get 2 times 9, which is 18, plus 9 plus 1. Do the arithmetic, you get 28. Okay, for the next one, this one's a little more difficult. Whenever you're plugging in a number or a variable expression, though, you want to replace the variable for the function by open parentheses and then fill in the expression. We're plugging in c plus 1, so we got to do 2 times c plus 1 squared minus 3 times c plus 1 plus 1. For the c plus 1 squared, you got to multiply it by itself, and you get c squared plus 2c plus 1. Distribute the minus 3 through, and you get negative 3c minus 3 plus 1. And then simplifying, it all works down to, after you combine like terms, c squared plus c. Okay, for the next one here, you want to find the equation of the line passing through these 2 points. You're going to use your standard y equals mx plus b, your slope-intercept form. And you got to find the slope, and you need to find the y-intercept. So our slope formula is y2 minus y1 over x2 minus x1. We plug in our points, our numbers from our points. The difference in the y's is y9 minus negative 1. Difference in the x's is 4 minus 2, so it gives us 10 over 2, which is 5. So once you know the slope, you plug it in immediately. So we plug in 5 for m, so we get y equals 5x plus b. Now to figure the other constant out, b, in the equation, you got to use that we have 2 points that lie on the line. If they lie on the line, they must satisfy the equation by definition. So we can plug in either point. Let's just say we're going to plug in 4 and 9 in for x and y, and then that allows us to solve for b. Okay, so we get 9 equals 20 plus b, and therefore we must have that b is equal to negative 11. Okay, now we're still not done. You found b, but now you want to write down your equation for somebody else to go and look at. So if they want to graph it, you get y equals 5x minus 11. Okay, continuing on, let's solve this question. We're supposed to find the equation of the line that contains the point negative 2, 1, and it's parallel to this line. So again, we're going to use y equals mx plus b. We need to find the slope. We need to find the y-intercept. We don't know either one of those by given this point, but it's supposed to be parallel to the given line, and we can figure that slope out if we know 2 points on there. We can see from the picture, from the grid, that to go from the point 0, negative 1 to 1, 3, we have to go up 4 and right 1. So our rise is 4, our run is 1, and therefore our slope is 4. So we can plug 4 in for m, and then you got to find the y-intercept. Like the last question, you're going to go and plug in the ordered pair, negative 2, 1 for x and y, and then solve the equation for b. Okay, because the point must lie on the line if and only if it solves the equation. So it must satisfy the equation after we plug in. After we do, we find that b is equal to 9. Add the 8 over, and then we make our conclusion. So our formula for this one is y equals 4x plus 9. Okay. All right, and we're not told to graph it in this case. We just write the equation down. Done. For the next question, you want to say after a 25% price reduction, 25% price reduction, you got to quote those phones selling for $48. What's the price before the reduction? So the original price in this case is the cost. So what we want to do is set up an equation that we're going to solve. Okay, so the original cost minus 25% of the original cost gives us the sales cost, or the final price. So that's what our equation is looking like. Now, we don't know what the original price is. That's our variable. Okay, so we're going to call that x. So in this case, we're going to have x minus, we're taking a percentage, so we're going to do multiplication. It's going to be 0.25 times, we don't know what the original is, so times x. And that gives us equal to 48. Now, in this question, we're going to solve for x here by combining the like terms together. And in this case, we get 0.75. We take the 1x minus the 0.25x, and that equals 48. So now we're going to divide both sides by 0.75 to get that x is equal to 64. Notice this last equation makes pretty good sense here because it's saying you take 75% of your original price, you get the sales price. Okay. Now, in this next one, the next equation, we're going to write that out, and then we're going to clear the denominators, clear the fractions out by multiplying everything by 12. We do that, multiply each term on left and right by 12, and we get the simplified equation 8x equals 72 minus 3x. And then you can solve for x, and you get, by adding the 3x to both sides, we get 11x equals 72, and therefore x is equal to 72 over 11. Okay, that's the solution to that linear equation. I'm going to solve number 10. I'll leave number 11 for you to do. Number 10 trips people up because there's no constant term. It's still a quadratic equation. You still want to put 0 on one side, all the other terms on the other side of your equation, and then we're going to try to factor. In this case, we can factor out 5x, and that leaves us 5x times x minus 4 equals 0. And so now we split this up by the zero factor property. One of these factors must equal 0, and therefore we conclude x is equal 0 or x is equal 4.